So there's been interest expressed in building this small controller that I mount directly on the back of the glove. This one is on the archery style glove. The one I'm building, this is from the how to make a glove video. This is the fingertip. Still haven't shortened those, but anyway. I'm actually gonna take this off of here and we'll put the controller underneath and we'll drive this glove off of that microcontroller. So in order to do that, I actually am using Arduino Nano. These are a knockoff that I got from Amazon. They come in a 3-pack. I think they're $19 for 3. And comes with the chip as well as what are called headers. So this is the Arduino Nano. Say it's a knockoff. It's a high-let go. The way you're supposed to do this, I guess the normal way, is you take these headers, you mount them onto the chip. Well, if I can get a header to hit. Like that and like that. And then you put this one on top. You solder those in place and you have a standard chip. You can buy them with the headers attached. However, I don't use the headers. So I just set those aside. So what we are going to do is, unlike the buzzboard that uses the Arduino Uno and a motor shield, the motor shield takes signals from the Arduino and converts those into the electrical signals that are sent to the motors. And the motor shield is certainly much simpler because you just screw things on, but also it gives you greater control over things that we don't really care about. Things like motor speed. You can vary the voltage that's being sent. You can also run forward and reverse. So you can imagine if you were building a robot or a toy or something. But for our purposes, we're not going to go that way. So what we are going to do is we are going to connect wires directly to pins. Let's see, the D3 for digital, D3, D5, D7, and D9. The selection of those is relatively random. When I first tried to build a direct drive without the motor shield, I did this on a solder breadboard, and I used terminal blocks so I could screw in the fingers, and a terminal block takes every other space. So if you put the terminal block to access D3, the next one that's accessible is D5, just because of the physical size. So I built that, I coded for it, it worked, and therefore when I moved to get rid of the breadboard and just go directly onto the board, I stayed with the D3, D5, D7, D9. It also does give me one space between the wires if I get a little sloppy on soldering, but this is going to be soldering. Okay. This is the same wire that I use for the fingers. I did get some solid core 22 gauge, which works quite well. I find that the insulator on this is a bit thicker. This is a solid core. This is a stranded core that I use for the fingers. And you can see the size difference. This is a bit harder to get through the case, so thus I'm sticking with the same wires that I use for the buzzboard fingers. These are a lot shorter, so I need, I don't know, what is that, like 3 inches? And I'll cut some of that off when I'm done. So I am going to take 4 of the red, 1 per finger. And I'm going to take one from the black because this runs a common ground. It can only run a common ground because we're grounding directly to the Arduino and it only has a ground. So we are going to do that. We're going to strip the end of the wires. Don't need a lot. Yeah, probably need a little bit more than that. Okay. So I have an exposed wire. I take these and twist them so they stay together. Makes it a little easier for the next step. The next step, I will need magnifiers. So now I'm going to take this exposed wire. I'm going to pass it through from the bottom. Oh, let me spin that a little tighter. And I am going to pass it up through D3. Once I have it up, I'm going to bend it over and it will just hang there. It's not very stable, but it doesn't need to be for the moment. Next wire through D5, again bend it over. Next wire is through D7. And again, these numbers are random, but the sketch that I'll put on the GitHub, I'll continue to use the Google Drive, but a lot of people have had trouble with the Google Drive for reasons unbeknownst. I've updated the link a couple of times. And then finally, I am going to pass, whoops, needs to be spun a little tighter than that. I had a spare wire. That can cause me problems. Okay, through the D9. Okay, so 4 wires. And then last but far from least, I'm going to come over here and you'll see GND is ground. And I'm going to pass the black wire up from ground and fold it over. And we will get to soldering. And we are going to solder these directly onto the circuit board. While we're here, one note, D3 is programmed to be finger 1. Just to go through it again, according to what Stanford put out and what is the bus board is programmed. 1, 2, 3, and 4. The way the sketch is written, D3 is 1, 5 is 2, 7 is 3, and 9 is 4. Now, once we get this thing in a case, of course, you're not going to be able to see that. However, this is the connector where we will program it and deliver power. And D3, which is finger 1, is the furthest from the connector. So once you get it in a case, if you can't remember which is which, just look at the order. Furthest from the connector is 1. Okay, let me get set up to wire this. Or I'm sorry, to solder this. Okay, so as before, D3, 5, 7, 9. We don't want to cross over to other ports now, or to other pins. We're not close enough that it really matters, but best to be tidy. Gonna heat up both the pad and the wire. Small amount of solder. That one's got a little bit of peak on it, but anyway. Heat up the pad and the wire. Small amount of solder. Pad and wire. I gotta clean up my soldering iron there. And then D3, pad and wire. Okay. And also don't forget ground, pad and wire. Okay, let's see what we've got. So now I have 5 wires connected directly to a board. You see I've got a little bit of extra wire hanging over here. It's not really going to hurt anything, but I always go through and trim for tidy. I'm sure there are some electrical engineers cringing at both my solder work and the solder direct to the board. Forgive me, but it does work. Okay. This is the case that I use for this. I mistakenly on the buzzboard said this was from Etsy. I actually get this from eBay. There are a couple of providers. If you think you're going to make a bunch of these or you have a printer, you can actually get the design for this. But this is an Arduino Nano case. Has a cap and a base, hole for the power. We do want to make sure we get the power connector toward the power connector end. So you'll find that these wires are just a little bit large to go through. I don't know if that's visible, but so they are a little bit on the large side to get through there. And that's simply solved. This is a screwdriver off a Leatherman, but any screwdriver will do. Again, you want to make sure power port to the power end. And I am just going to turn these just a little bit in order to get a wire through. So just a little bit of extra space. Apologize, I don't think you can see this very well. So what I'm doing is this. I'm taking this screwdriver and I'm just opening that gap a little bit so I can slip the wire through. Maybe I can do it from the back and it'll show better. Unfortunately, if I make it so you can see it, I can't see it. See, wire through. Wire through. Wire through. And then the fourth one. And see, it clamps down on them, which also provides a little bit of strain relief. Not a bad thing. And then I'm going to bring ground through because we need it. Okay. And now I'm gently going to pull these down. So I get that Arduino to lock down into that case and it fits nice and snug. Okay. You'll see where I didn't tidy the wires up quite enough, but it will still be okay. Okay, so what I end up with is an Arduino in a case with 4 red wires and a black wire coming out of the bottom. Case clicks shut. mini controller. That's it. Okay? You see that angle is because I didn't tidy the wires up on this side a little bit, so it's a little cantilever, but won't hurt for the final effect. Again, prototyping here, so off we go. Next step, I'm going to take this off of the glove. Okay. Get rid of that old cable tie. So, connector, walk through how that runs on the previous. So, when you're putting this together, you see everything comes in here to ground. So I try to turn so ground is on the end, so it's closest. Now that means that I'm going to end up with 1, 2, 3, 4. Personal preference, doesn't matter, whatever makes you happy. Okay, so same cable ties we've been using all along through this. Just a regular cable tie. I'm going to take this. I'm going to be careful I don't do anything nasty to these wires down here. Okay, so I don't want to be cranking on those too tightly. I'm going to bring the cable tie around. You do want to make sure you don't get this, the coupler on the cable tie underneath, because you're going to have a hard time getting it flush to the glove if you do that. Okay. And then same drill, watch your wires, pass your cable tie through. Give it a tug. Clean up the extras. And there I have the microcontroller terminal block on it. So now I'm going to strip these and I'm going to insert them in. The one thing you want to make sure of is, let me see where my screwdriver is. Okay, the one thing that you want to make sure of when you're doing this, I mean, obviously you don't want to cut your wire too short or you have to go solder again, but you don't want to end up with a picture like this, where you've got this big loop of wire. I mean, these things are gloves. They're going to be moving, wearing them a lot, hopefully. And so anything that ends up looking like a big loop of wire sticking out is going to get hooked on something. They're going to get pulled, okay? So what I do is I take these things and I bring them up. Now this one's pretty good length. Looks like I did better on the reds. Because I want to be able to insert them past this terminal block, this screw, right? Because that's what's going to hold it down. But I don't want to have a lot of extra wire hanging around. So we're going to strip these down. The reds look like they're a good length. The reason, even though I cut them the same, the reds are a good length and the black is long. If you recall, I passed the reds all the way under the nano case, the Arduino case, to get to this side. I could use a little bit more stripped off. Okay. So if you recall, power means closest to 4, 4, 3, 2, 1. So now I am just going to take these guys, give them a little twist so they're easier to manage. And that's going to be too long. See that loop of wire? That's going to be too much. I don't want that. Snip that off. Strip it again. And connected. Actually, looking in the end of that, I'm not real thrilled with that connection. I'm going to do this one again because I want to make sure I've got a really good mechanical grip there. You know, the whole sleeve of this and the terminal block is a good conductor, so I'm not worried about passing electricity so much as I want to make sure that wire stays put, because in my case she'll be wearing these and she'll be up and around and doing things, and which is a wonderful thing, but it's a little tough on a glove. It's fighting back a little bit. This is the challenge, that you don't want that wire to be very long, but it also means you don't have a lot of wire to work with. So just guided it in with the tip of the screwdriver and trim this one. Okay, so I've got a ground that's working loose there, but I'll get that. So I have this microcontroller. This is the Nano Arduino. Again, it's the High Let Go knockoff. This comes in a 3-pack. But, you know, nothing against, that's a little loopy and long. I'll shorten that. Nothing against the Arduino. Great product. Love to sponsor them. They do good work. So the last steps here, we need to get this attached to the glove. We need to put our cable tie back here. So we've got strain relief on these fingers. So we're gonna, as we did in the previous, put a cable tie here. The one thing you're gonna run into is using these little cable ties. As you saw, they're just barely long enough to go around the terminal block and the controller. They're never gonna make it all the way around both. So what I'm gonna do is this. I'm going to take 2 cable ties, and you see there's like the bump on the back and they're flat on this side. So I'm going to make sure those stay the same. And I'm going to pass one into the other. until it clicks. And now I have a cable tie that's twice as long. So I'm going to take this. Actually, I'm going to go down from the top because I don't want to leave those bumps down against her wrist. Goes down, goes up. Okay. And now I'm just going to take this assembly. I'm going to bring this up between my wires. I don't need to be tugging on wires. They'll get enough tugging as we go anyway. Okay. Going to pass it between. And now I just need to snug it down tight. Tighten there. Tighten here. Be careful with my wires. That is the small controller attached. Again, I'll put a cable tie here so I can get some strain relief on these because these are going to get tugged. But I need to shorten these. She does not have Area 51 alien fingers, so I'll do that as a next step. But now that I've got a controller on here, all I'm going to do is program this. It takes a different sketch, and if you go with these Hi-Let-Gos, it takes a little bit different. It's still the Arduino IDE, but you don't identify them as nanos because they used a different firmware. But I will step through that in a screen share. And that is taking an Arduino Nano knockoff, a case that I got off eBay. There are a couple providers, but since this one has, looks like this came from propsandtreasures.com, but there are a couple providers. You can use code THANKYOU15. So that's it. I will go ahead and build another one of these because I have a second glove to build, and we will move on to the screen share with the IDE on how to program. The Arduino Nano, or high-tech knockoff that is in the microcontroller, uses a different cable. So you'll see this is a USB mini. You will need to have a cable that matches to the controller that you have. They could be a mini, as in this case, a micro or USB-C, doesn't matter a whole lot. Looking in this array, we'll be using this Vibrotactile 3V. This timer is for both the length of the pulse as well as the pause. Now, if you look at the task document, you will see that the text says a timer of 100 milliseconds. If you put a ruler on their diagram, you will see that that calculates out much closer to 166, 67. Full disclosure, the first one of these I built to a 167 pulse length and pause for my wife, and that's the one she's using. So this can easily be changed and still be interpreted to be compliant. The init LED pins is the order in which the pins will be fired. The pin count represents the number of integers that are in that array. If you recall, when we did the soldering, pin 3 is finger 1, pin 5 is finger 2, 7 is 3, and 9 is 4. So this is going to fire finger 3, 2, 4, 1, 1, and on. You also see a 13 in there. 13 is the pin that turns the light on the controller. It was the green light on the Uno. It's a red light on this device. It shows that it is operating. It also provides the pause that is part of the Stanford design. So that is the way that this instantiates that Stanford pattern A from the paper. This goes through the setup. So it spins up and makes sure all the pins are properly initialized, and then it begins looping. And the loop goes through the number of pins that number integer that was set before, the 32, and it will continue in a circle to run through each of those pins in order and then pause for the period of the that timer. And as I mentioned, it is 100 in this code. If you look at it, it could be 167 depending upon interpretation. You'll notice at the top it says an Arduino Duomilanova is on COM3. I've already connected this device once. Because this is a high-tech knockoff, it does not show up in the IDE as a Nano. It shows up as this Duomilanova. Dug that out of the high-tech website. Wasn't really obvious, but it's there. So in order to get this thing properly programmed, we're going to need to select what type of device it is, because it may well show up and think it's a Nano or an Uno. And we have to go in to scroll around until we find it. They're alphabetical order there. Duomilanova. COM3 should already be filled in, or whatever COM port it's on, because it should have discovered there's only one attached. And now we have it set up. All we need to do is take this sketch, load it into the device. We hit upload. It's compiling sketch, loads it, and we are off and running. And so now we have a programmed microcontroller that is running the Stanford A pattern with 100 millisecond pulse and spacing, and it will continue to operate in series. These are the ones that I use on the back of the glove. I find them to be very convenient. She's very mobile with them. All that being said, the standard disclaimers, no warranty express or implied. This is merely my interpretation of what those documents say. Clearly, others may have other interpretation. No warranty express or implied. Your mileage may vary. We have had very good success with these and continue to. So I hope that this will bring the same benefit to others that it has for my wife. And have a great day. God bless. And we have set up a discussion group on the GitHub. And feel free to jump in, comment, question. You can email me as well. So God bless. Have a great day.